Scooping over 100 tons of fragmented kimberlite ore in a single pass, the shovel dwarfs the waiting haul truck, maintaining a non-stop procession.
The shovel's movements are a continuous, fluid cycle. It digs, swings, and dumps with surprising grace. Inside the gyratory crusher, the immense grinding force reduces massive boulders to manageable pieces.
Inside the processing plant, the ore is fed into enormous, rotating drums called scrubbers. As the drums spin, the rocks tumble against each other. As the drums spin, the rocks tumble against each other, and water is sprayed inside, scrubbing away dirt and breaking down softer materials.
Check the cyclone pressure, it's slightly elevated.
Confirmed. Making the adjustment now.
Facets. This mixture is pumped at high pressure into a large, cone-shaped vessel called a cyclone. The slurry spins rapidly.
The ore is mixed with a carefully calibrated slurry of water and ferrosilicon, which has a very high specific gravity. This mixture is then pumped at high pressure.
Inside the cyclone, the magic happens. The heavier elements sink, exiting through the bottom. The wet gravel carry the first glimpse of rough, uncut diamonds. A robotic arm periodically takes.
In a stark contrast to the valuable concentrate, a massive conveyor belt dumps the worthless, lighter kimberlite waste material onto a colossal man-made
Blizzing. In a stark contrast to the valuable concentrate, a massive conveyor belt dumps the worthless kimberlite waste.
Most diamonds have a unique property. They fluoresce, or glow, a bright, visible blue when exposed to X-rays.
Most diamonds have a unique property. They fluoresce a bright, visible blue when exposed to X-rays. The process is incredibly fast. A diamond glows, and a puff of air immediately knocks it aside.
The diamonds are lowered into a fuming bath of hydrofluoric and sulfuric acid. This dissolves surface impurities, cleaning.
This is the raw material for the cutters.
The journey from the remote mine to the global cutting centers has begun.
The diamond's precise weight and dimensions are meticulously logged before the scanning process begins.
The lasers map not only the external shape, but also penetrate the stone to pinpoint the exact location, size, and type.
This automated laser sawing machine uses a hair-thin beam to meticulously carve the rough stone, vaporizing the material at the point of contact.
A polisher applies a mixture of oil and micron-fine diamond dust. Since only a diamond can cut,
the bruted diamond is held in a mechanical clamp called a dop. The polisher carefully lowers the dop, pressing. Using the mechanical dop, the polisher presses the rough stone against the scaphe, transforming the opaque surface into the diamond's largest facet, the table.
The polisher carefully lowers the dop.
The finished diamond is placed in a wire basket and boiled in acid, then steam cleaned. A powerful jet of steam ensures Once logged into the system, the diamond begins its journey through the grading process, moving automatically from station to station for analysis.
I'm placing it right here at E.
Confirmed. It matches the master stone.
This one is definitely an E.
I concur. It sits right on the E line.
The diamond is placed on a highly accurate electronic scale, enclosed in a glass case.
The laser inscribes the unique grading report number onto the diamond's girdle. A gemologist then uses a microscope to verify the inscription is correct.
A pleasure doing business with you. Likewise. Likewise.
Onun gandung rokat okim yatrai mi pong samina, breaking orang yang niskia pramhanatma. Yeroban lapop nir ing dang dudek.
It's beautiful. It's perfect.
Ни Тимур Тодомня, я палкотик дымит мнат видол даст ни палк ни тристубнут, набидидун притам дрикону ницнах.